Hi everyone, Kevin from CyberMook. Today we are going to do a short video on cryptography. It's going to be a short course that's going to explain to you what is encryption, what is hashing. So hang on and let us know if you have questions in the comments. What is cryptography? Cryptography is the practice of securing networks by transforming data into a form that cannot be understood. So you know how you tell a secret to someone, right? Or you have a coded language with some of your best friends. That's the same principle with cryptography, transforming data into a form that cannot be understood. It's only meant for specific people. So cryptography has two important concepts, encryption and hashing. So first, encryption. Encryption is a method of transforming readable data into an unreadable form. The readable data is called plain text. So anything that you can read like this text is called plain text. The unreadable form is called ciphertext. Those are things that you see, but you're not able to understand, you're not able to make sense out of them. So once the plain text is transformed into the ciphertext, humans cannot understand or make sense out of it. So plain text, what you can read, what you can understand. Ciphertext doesn't make sense, it's too complex. That's the process of encryption. And encryption uses something called keys. It's just like a piece of code, keys to encrypt the data. So to make the readable text unreadable. Now, decryption is the opposite of encryption. Decryption takes ciphertext, the unreadable part, and converts it back to plain text. So it does the opposite of encryption. So here's a short illustration on encryption and decryption. Encryption says, this is a plain text, you want to send it to your friend. It says, today we are studying network security. Readable, everyone can understand. So you added a key to that message, and what it does, it creates a ciphertext. Now, nobody can understand this, nobody can read this. So while it's being transferred through the network from your phone to your friend's phone, nobody can read that. And now when it reaches your friend's phone or the destination, the website, wherever it's intended to reach, it is decrypted. So the ciphertext is decrypted back to a plain text. And it uses keys. Keys are just like pieces of code to encode or decode a message, right? So encrypt and decrypt a message. So that's encryption. And there are two types of encryption. We have what we call symmetric encryption and asymmetric encryption. Those are like the two types of encryption. Symmetric encryption is a type of encryption where one key is used for both encryption and decryption process. Just like we just saw, you can encrypt and decrypt with the same key, with the same piece of code. So here you have encryption, you're encrypting a picture, you can encrypt anything. It doesn't have to be a text message, it can be an image, it can be a video, it can be any type of document, any type of data you can encrypt. So you use this key. This is just a random name called private key 12, PRK12, and it generates a ciphertext. Now, to decrypt this message, to get back to the original version, it can only be done with the same key that is in symmetric encryption to get back to the original version. So symmetric encryption uses the same key for encryption and decryption. You can only use that key, that's symmetric encryption. So now you can already guess what's the other type of encryption. Asymmetric encryption uses two keys. The public key, which is accessible to everyone, and the private key, which should never be displayed. One key is used for encryption, the other one is used for decryption. And the two keys are kind of related. So asymmetric encryption, first, two keys are generated. So the computer generates two keys, one public, which we call here PUK45. Don't worry about the name, it can be any name. And one private key, PRK45, so public and private. Now what happens when you encrypt the key or a data with a specific key? For instance, if you encrypt with the public key to create the ciphertext, now this time, if you want to decrypt this, you'll have to use the corresponding key, so the private key, to get back to the original version. So that's asymmetric encryption. It uses two keys, the public key and the private key. Public key can be known to everyone. It's available and it can be seen by everyone. The private key should never be displayed, should never be known to anyone. The public key, you can see the public key for any website. For instance, if you go to just randomly CNN.com, and now you go and check the certificates, which we will talk about. You are going to see their public key, which is displayed to everyone. Meanwhile, the private key should never be displayed. Asymmetric encryption is just like keys at a bank with a safe. Like if you've ever had a safe at the bank, you need two keys. You need your own key and the bank key. So the bank key is kind of like the public key, and your own key is like the private key. Without your key, it cannot open. Without the bank key, it cannot open. So it needs the two keys to open the safe. Keys, like we mentioned, are the types of secret codes used to perform encryption or decryption. You can encrypt with a key, you can decrypt with a key, and you have public keys that are shared openly, like I showed you for CNN. Public keys are used for encryption and decryption, they are shared openly. Private keys are only known to the key owner. And then some people have a key escrow, which is like a third party that's used to store keys. So to summarize the difference between both symmetric and asymmetric encryption, symmetric encryption uses one key for the process to encrypt and decrypt. Only one key is used. Asymmetric encryption uses two keys, a public key and a private key. In symmetric encryption, the key always has to be private. It should never be known to anyone else. In asymmetric encryption, two keys are used, a public key and a private key. Public key is known to everyone. Private key should never be known to anyone else. Anything encrypted with a private key can only be decrypted with the same key. In asymmetric encryption, if one key encrypts, the other key decrypts, and vice versa. Now, if you're studying for the CompTIA certification, there are a few other types of encryption that you might see there, which I wanted to share with you guys. First, you will see something like full disk encryption. Full disk encryption is like you have your entire hard drive. This is just a sample with a few documents, like a document, pictures, videos, PDF documents, etc. Full disk encryption will mean encrypting everything in that hard drive. Partition encryption means the disk is partitioned, so it's broken down into different parts, and you can decide to encrypt only part of that disk. That's partition encryption. The other content is not encrypted, but you might want to have some separate files or in a separate partition that you encrypt. File encryption, just like the name says, is encrypting only one file. So here, for instance, we're encrypting the family pics, but the rest is still in the publicly available version. Now, to perform encryption, you need some tools, right, within the computer. So there are some specific encryption tools. First, you have one tool called the TPM, Trusted Platform Module. What is this? This is a chip that is integrated into the computer, and it provides cryptography. So that's called the TPM, Trusted Platform Module. When the computers are manufactured, it's added on there, and it does all the computation and encryption and all that. And you have another tool called HSM, Hardware Security Module. This is very similar to TPM, but these are removable devices, so they can be added or removed to a device. A similar concept to encryption is called hashing. So this is one of the fundamental concepts of cryptography. What is hashing? Hashing is a process that transforms data into a fixed size string of characters called a hash. Hashing is an irreversible process. You cannot retrieve the original data with the hash. Once it's done, that's it. So once you convert data into a hash, you cannot go back to the original version. Any change in the original data will result in a completely different hash value. So if that's how your passwords are used are stored online. When you enter your password, when it goes to the destination website, it's not stored as the original text value, it's stored as a hash. So they cannot know what your password is because they cannot get back to the original version. So, and I'll show you a quick example here on some publicly available sites. Let's say I want to enter my password, I love cyber security, with some special characters. This is the password here, and then this is the result, the output here. So whatever I change in the input, if I add a character, you will see on the right that everything completely changes. Like add a character, but if I erase that, we get back to the original output. So that's how hashing works. It gives you like a corresponding value based on the original value. So two people can have the same password and will have the same resulting hash. How can you be certain that the message you received was not modified? If I send a message to someone or if I download something, how can I be sure that that message or that file was not modified? That's hashing comes into play there as well. So if I send a message to someone and I say, "Hi, how are you today?" This is the corresponding hash result of that message. Now, if someone alters the message and replaces "hi" by "hey," you will see that the output will completely change. So hashing enables or provides integrity. If you change any tiny thing, like just add a space to the original message, it will completely change the resulting output. So here we have an example here of Celia, who is trying to create an account on Facebook with the password "I love cybersecurity." Now she creates her account, she enters her email, and she enters her password. Now what happens is that Facebook will only have the hash of her password on their end. They will not have the original password. They will only have that resulting value that doesn't make sense. So they will add it to the list of their passwords, and they will not have the original password. So the next time she connects to Facebook, Facebook will compare her hash with what they have in the system. And if it corresponds, then she will be connected. That's how hashing works. Now the problem with this is that two people can have the same password and will have the same hash. So it will be easy to know or to guess someone's password if they have a common password. So this is where salting comes into play. A salt is a unique value that can be added to a hash to create a completely different and random value. So a completely different new random value from the original value. Salting protects passwords by making hash values even more randomized. So the hash value is completely different from the original value. And this adds security by making the hash unpredictable. If two users share the same password, their hash passwords will be different because the salts are unique. So let's see what that looks like. Imagine that your password is January 25, for instance. And you have a friend whose password is the same. So I'll copy that here on the same. So this is your password, January 25, your friend's password is the same. If you pay attention, you will see that the hash are the same. So let's take note of the last three values, CA7, CA7. Now, if you have a salt, which is a random value for the different people, for instance, for you, your salt can be the @ maybe 3 times, and for your friend can be the question mark 3 times. This is just random. I'm just getting it out of the blue. You will see that even though you have the same passwords, when you add some salt to it, the password hashes are different. So this is B91 and the other one is 8C9. So this is how salting works. Salting adds some special characters to hashes to make them completely unpredictable. So let's take an example here. Here you have 3 people with their passwords. You can see that Eva and Paulette have the same passwords. Now, when Eva, the hash is performed on her password, Eva and Paulette have the same hash result on their passwords. Now, what happens when you add some salt to the password? Eva and Paulette have different results at the end. So that's how that works. And so at the end, someone at Facebook will not know that Eva and Paulette have the same passwords. So this is to make even more unpredictable and for more security. So that's how salting works.
All right, guys, what did you think of this course? You liked it? Great. We're glad you did. You can follow us on all our social media platforms, including YouTube, TikTok, Instagram, and Facebook. And don't forget, we also have these awesome flashcards to help you study. So definitely check out www.cybermook.com to order yours today.